We will wait for one more minute because only nearly 30 students are joined. I'll wait for 11:21. Just start at 11:21. Okay, we'll start. My voice is audible. Okay, my voice is audible.
Yes, sir, sir.
Okay, just still now we have seen scales. Okay, why we are going for scales? So there are two reasons. When the size is big, but I want to draw in a drawing sheet, so that time we'll go for scales. But when the size is very small, but I want to draw in the drawing sheet, we have to go for some scales, either enlarging scale or reducing scale. So as of now, we have seen plane scale. So that is 2 units, but only two decimal. There is only single decimal if you use plane scale. But if it is a last class, we have seen diagonal scale. But three consecutive units we can able to draw in a sheet. So last class we have seen foot, inch, and yard also we have seen last class. So 3 units, three consecutive units, but two decimals. So that's about diagonal scale. But Vernier scale, but two decimal. That means after point. So 19.26, 19.27 like that. After point, you can able to measure 2 units. So two decimal. So diagonal and Vernier scale, you can able to measure two decimals. That is after 19 point means 19.26, 19.27. After dot, after point, we can able to measure another two decimal. But if it is a plane scale, only one decimal. But Vernier and diagonal scale, we can able to measure two decimal. But plane scale and Vernier scale, only 2 units you can able to do it. Okay, in the scale we can able to draw only 2 units. But diagonal scale we can able to we can able to mention three consecutive. We can able to mention three consecutive units. And we'll just see one more. As of now, we completed a plane scale problem. So diagonal scale and diagonal scale problem. We'll just see Vernier scale. I already told you. So if you want to measure small units very accurately, we can go for Vernier scale. So there will be a main scale and Vernier scale. So if you take a Vernier caliper, so there are main scale reading and Vernier scale reading. So similarly here also in the scale, we have main scale as well as Vernier scale. You have main scale as well as Vernier scale. When the dimensions are very small, okay, I want to measure diameter of the rod or a small range of linear dimension. Okay, when the range is very small, so we can use Vernier scale. We can use Vernier scale. Okay, just note on this problem. Okay, I think my screen is visible. Just pin my laptop. Okay, just pin my laptop screen. Just pin my laptop screen. Uh, so my screen is visible. Visible abba? Terida. The screen terida. So pin my laptop screen. Pin my laptop screen. Okay, after we'll just see the problem here in the video, and same problem I'm going to do it manually also. Okay, the drawing sheet I'll do later. So first we'll see the problem in a video. Okay, this is the problem is given. Okay, draw a Vernier scale. It is given like this. Draw a Vernier scale. Okay, draw a Vernier scale of representative factor 1 by 25. Representative factor 1 by 25 to read centimeters. The maximum, that is maximum length to be measured is 4 meters. That is given. Maximum length to be measured is given 4 meters. Maximum length to be measured is given 4 meters. Maximum length to measure is given 4 meters. Okay. Okay. So representative factor is given 1 by 25. Representative factor is given 1 by 25. 1 by 25. The maximum length to be measured is, the maximum length to be measured is 4 meters. But if you want to convert to the mm, it will be 4,000 mm. It will be 4,000 mm. It will be 4,000 mm. So we know 1 meter is 1,000 mm. We know 1 meter is 1,000 mm. So 4 meter is 4,000 mm. So we have to mark after completing the Vernier scale. So that is main scale and Vernier scale. We have to mark a distance of 2.39 meters. Just see the decimal, 2.39 meter. After point, there are two decimal. But plane scale only one decimal. If the diagonal scale and Vernier scale, we can able to measure two decimal. Sometime if the word is not given, okay. Sometimes in the problem, if the word is not given, plane scale. You should mostly draw a plane scale, draw a diagonal scale, draw a Vernier scale. The word will be there. If that word is not there, okay, sometimes it will be given 0.98. Either you can follow Vernier scale or diagonal scale. Sometimes it will be given yard, feet, inches. The only option is you have to go for diagonal scale because three units. So if it is 2 units, so we can go for plane scale as well as Vernier scale. If it is single decimal, we have to go for plane scale. If it is 2 decimal, we can go for Vernier scale as well as diagonal scale. But if it is 2 decimal, either we can go for diagonal scale or Vernier scale. But if it is specified, if it is usually in the problem, it will be given, use the plane scale, Vernier scale, diagonal scale. So if it is not given, so based on the problem, if 3 unit is given, only option is you have to go for diagonal scale. If it is 2 units but single fraction, if 2 units, show a distance of 2.9 meter, show a distance of 2.9 meter, we have to go for plane scale. So 2 units, but it is given a value of 0.98 meter, that is 2 decimal. You have to go for Vernier scale. Okay, is it clear? So if it is a plane scale, 2 units, but single decimal. If it is a diagonal scale, 3 units, but 2 decimal. But if it is a Vernier scale, 2 units, but 2 unit as well as 2 decimal. 2 unit as well as 2 decimal. Okay. So here representative factor is given, maximum length is given. Maximum length is given. Okay, maximum length is given 4,000. So we know length of scale. We know length of scale is, okay, length of scale you want to mark in the drawing is RF into maximum length to be measured. Representative factor into maximum length to be measured. Representative factor into maximum length to be measured. So this is a formula we already know. You have to remember this. So representative factor is 1 by 25. 1 by 25 into 4,000. 1 by 25 into 4,000. You'll get something 16. You'll get 16 centimeter. You'll get 160 mm or 16 centimeter. 160 mm or 16 centimeter. You get this. Okay. Just see the video. And after completing the Vernier scale, okay, after completing the Vernier scale, what you have to do? You have to mark a distance. You have to mark a distance of 2.39 meter and 0.9 meter. You have to mark a distance of 2.39 meter as well as 0.9 meter. I already told you in the Vernier scale there are two methodology. Okay, so you can follow backward Vernier or forward Vernier. But I'll solve the problem based on backward Vernier. But I'll tell you what is forward Vernier. You can follow any method. Okay, you can follow any method, backward Vernier or forward Vernier. But I'm going to use only backward Vernier. But I'll tell you what is forward Vernier. But I'm going to solve the problem based on only backward Vernier. But I'll tell you what is forward Vernier also later. Okay, just see the video. Okay. So this is the data given. RF is given 1 by 25. So maximum length to be measured is 4 meters. So from the calculation we got length of scale is 160. Length of scale we got is 160 mm or 16 centimeter. 160 mm or 16 centimeter. So from calculation, length of scale is RF into maximum length to be measured. So here 1 by 25, 1 by 25 into 4. So 1 meter is 100 centimeter. 100 centimeter. So if you want to get directly in centimeter, 100, you get the value of, you'll get a value of 16 centimeter or 160 mm. You'll get a value of 16 centimeter or 160 mm. Then what you have to do? So you have to draw a horizontal line. You have to draw a horizontal line. So what is the length of this? Equal to, that is length of scale, equal to length of scale, equal to length of scale, that is 16 centimeter, equal to 16 centimeter. You have to draw a horizontal line. So based on length of scale, so you have to draw a horizontal line, and you have to draw a, you have to make this as a rectangle. You have to make this as a rectangle. You have to make this as a rectangle, because scale has some size, there are some height. You have to make this as a scale. You have to make this as a scale. Here, what are the two units? Meters and centimeter. What are the two units you have to measure? Meters and centimeters. So why you are dividing into 4? Because maximum length of the scale is given. Maximum length of the scale is given 4. So we have to divide 16 divided by 4. We have to divide 16 divided by 4. So we have to divide it into 4 equal parts. With 4 centimeter, 4 centimeter, 4 centimeter, we have to divide it into 4 equal parts. Into 4 equal parts. Okay. So this length is 16 centimeter. This length is 16 centimeter. So this length of scale you have to mark 16 centimeter. So why I am dividing this into 4? Because maximum length is given. Maximum length to be measured is given is 4. So you have to divide into 4. We have to divide into 4 equal parts. You have to give a name of here 0. Here also 1. So this is called what? This is called secondary division. So the 0 to 1 to 3 is called primary. This is 0 to 1 to 3 is called primary division. Okay. And we have to divide this into 10 division. We have to divide this into 10 division. So what is the value of each? What is the value of each? This is 0. This is 0. This is 1. So between 0 to 1, if we divide it into 10 equal parts, what is the value you get here? Each unit is 0.1. Okay. If you have possibility of dividing into 100, but what is the value? So 1 divided by 100. But what I'm doing here, this between here, there are only 10 division. This unit is 1, but I'm dividing this into 10 subdivision. But what is the each value? 0.1. What is the next value? 0.2, 0.3, 0.4, 0.5, 0.6. If it is 0, 100, for example, if it is 0, 100, if you divide into 10 subdivision, what is the each value? 10, 20, 30. Okay, that depends on the magnitude. Okay. It depends on the magnitude as well as unit. Depends on magnitude as well as unit. If it is 0, 100, what you have to do? We have to divide 10 subdivision means what is the each value? 10, 20. But here also 1. So here also 1. So here meters. This also meters. But if you divide into 10 subdivision, what is the each unit? This is 0.1 meter. Okay, 0.1 meter, 0.1 meter, 0.1 meter, 0.1 meter. Okay. Okay, then what you have to do? This is most important. I'm going to use, I already told you, backward scale. So you have to mark a distance 0.1, 0.2. Here it is given. It's not given clearly, but there is a point is there. Each subdivision is 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 up to 0.9. So last unit is 1. So we are divided into 10 equal parts. So each subdivision is secondary division is 0.1, 0.2 like that. Then so these most important steps for Vernier. If you want to use Vernier scale problem, okay, if you follow backward Vernier, just listen. This is most important, very important step for backward Vernier. So what you have to do? Equal to the same subdivision. Okay, if it is a backward scale, so what we have to do? Equal to this. If the value is okay, if actually this value is 4. This value is 4. So what is the each subdivision will have a 0.4, 0.4, 0.4. Then you have to take one more 0.4 here. You have to take one more 0.4. Okay, you have to take one more 0.4. One more time. If it is a backward Vernier, so what we have to do? Each subdivision is 0.4. This problem 0.4. So what we have to do? So from here with the value of 0.4, locate a point here. From here with the value of 0.4, you have to locate a point here. Okay, from this, draw a vertical line. Okay, from this, draw a vertical line. Connect this. Okay, what I done here? This is method for backward vernier. This is a methodology for backward vernier. I already told you, if it is not specified, you can follow backward vernier or forward vernier. There is nothing wrong in that. Okay. But I'm going to use backward vernier, but I'll tell you what is forward vernier later. But that methodology I'm not going to apply. You can apply any method. There is nothing wrong in that. Okay. So what we are to do, if we divide this into 10 subdivision, we have to take additionally 1. We have to take additionally 1 equal to this subdivision value. Okay, equal to this subdivision value. Okay, this problem. So this value is total length is 16 centimeter. So that is we are divided into 4 means 4 centimeter, 4 centimeter. But 4 centimeter divided by 10 subdivision means 4 divided by 10. So each subdivision is 0.4. So from here with the value of 0.4. This problem 0.4. Okay, if it is some other problem equal to this one subdivision, equal to one subdivision. So just extend this line. Just extend this line. So from this, draw a vertical line. So draw a horizontal line and draw a vertical line. So this is your vernier scale. This is your vernier scale. This is your vernier scale. And what you have to do, if it is a backward vernier, if you follow backward vernier, so what you have to do, you have to measure the distance. You have to measure the distance of this. You have to measure the distance of this. What is the length will be? So already this is okay. Okay, this up to this. Each subdivision is 0.4, 0.4, 0.4, 0.4. So this is 4 centimeter. So here additionally 0.4, you'll get 4.4 centimeter. You'll get this. This width is 4.4. You'll get this width is 4.4. So this total length is 16 centimeter. This is you'll get 16 centimeter. Okay, this is 16 centimeter. So what we have to do now? This we have to divide into this. We have to divide into 10 subdivision. This 4.4 we have to divide into 10 subdivision. 4.4 we have to divide into 10 subdivision. Okay, you can follow scale. Already you know on some methodology. You have to draw inclined line. So that we have to do 10 equal parts. So that last point and this point connect. And from that you have to draw a parallel. The same methodology what you applied in cycloid. And we applied in some other methodology, some other problem also. Okay, that is fine scale, vernier scale also we can apply. So same methodology you can apply. But what I'm going to do, this is 4 point. So I'll repeat one more time. So 16 centimeter, draw a line here. So make a scale. Yeah, 16 divided by maximum length is 4. So 16 divided by 4, just divide it into 4 equal parts. So 0, 1, 2, 3. This area you have to give 1. So this I'm dividing into 10 subdivision. This I'm dividing into 10 subdivision. So this is 1 means, so 0.1, 0.2, 0.3 up to 0.9 and 1. Then what you have to do, from this equal to this one subdivision, equal to one subdivision, just extend this line. Equal to this subdivision, just extend this line. Equal to this one subdivision, extend the line, and from that draw a vertical line, draw a horizontal line, and draw a vertical. Just close this. Just close this. Then what you have to do? What is the length of this? This is 4 centimeter. This is 4 centimeter. So this length is, this problem you're getting 4.4. This 4.4 we have to divide into 10 subdivision. Okay, you have to divide into 10 subdivision. I don't know, somewhere you'll get somewhere in the middle also. You divide into 10 subdivision. Just divide this into 10 subdivision. Divide this into 10 subdivision. Just watch it. Just dividing this into, we are going to divide this into 10 subdivision. We are going to divide this into 10 subdivision. You have to make a rectangle, and that you have to divide into 10 subdivision. You have to divide into 10 subdivision. Okay, just listen. Okay, what we have to do? We are taken. Actually, what is the? Actually, this length is, what is the length of this? Only 10. What is the total length of this unit? What is the total length of this unit? 11 subdivision. We are taken 11 unit as a 10 subdivision. Actually, this length is only 10, but we are taking extra 1. Okay, what is the length? What are the length of the subdivision? We have to extend that. So we are taking, this is 11. We are taking, this is 11. So we have to take 11. We have to take 11 subdivision into 10. So what is the least count of the vernier? 11 into 0.01. You know least count of the vernier caliper is. Least count is 11. Actually, we are taking 11 division into 10. We have to take 11. What is the least count of the vernier? 11 into 0.01. 11 into 0.01. 11 into 0.01. Then what you have to mark here? So what is the first unit means? 11. So this is, if you take from this side, so 11 into 0.01, you'll get 0.11. You'll get 0.11. Okay. Then, so next unit is, so this is 0.11. This is 0.11. What is the unit you'll get? 0.22. What is the next unit? Okay, up to this 0.22, another 0.11. You get 0.33. You get 0.33. This is 0.44. So this is 0.55, 0.66, 0.77, 0.88, 0.99, and 1.1, and as well as 1.1. Okay. So why I'm taking this? Because actually only 10 subdivision, but we are extended one more subdivision, 11 subdivision. We are taking 11 subdivision into 10. So we have to divide. That is 11 into least count. Least count of the Vernier is 0.01. So 11 into 0.01. We get each subdivision is 0.11. Each subdivision is 0.11. So next subdivision is 0.22. So 0.33, like that. We have to mark. We have to mark like this. So upper thing is called Vernier scale, bottom is called main scale. So we completed, but we have to mark. We have to mark 2.39 meter and 1.9 meter. Just see the value. It is marked. So 0.11. So from this side, we have to take. Okay. The direction is from here. The direction is from here. That's why it's called backward vernier. If you follow this direction, that is called forward vernier. That there are some one more difference also. We mark 0.11, 0.22, 0.33, 0.44, 0.55, 0.66, 0.77, 0.88, 0.98, and 1.1, not 1. Okay, next division is 1.1. Okay. So problem is over. But we have to mark. We have to mark. I'll tell you one simple methodology. Whatever the data is given, they asked to mark a distance of 2.39. They asked to mark a distance of 2.39. They asked to mark a distance of 2.39. So at the last digit, where you're getting 9, you're getting 0.99. Okay, you just follow the simple methodology. So what you have to do? The last digit is 2.39. So from this. So what you have to do? 2.39. Okay, 2.39 up to this what? So if you measure from here, up to this, what is the distance? 0.98. If you measure from here, what is the distance of this? 0.98. Okay. Just subtract. Okay, what is the reading of this? 0.99. What is the reading of this? 0.99. So 2.39. Why I'm taking 0.9? Last digit you have to take same thing. If the value is 2.38, the value is 2.38, we have to take 0.88. Okay. Based on the last division, second subdivision, we have to take. Second decimal, we have to take 2.39. So we have to take only 0.9. If it is 1.7, 1.77, we have to take 0.77. If it is given 2.33, we have to take 0.33. Okay, depends on last. So 2.3 means we have to take 0.9. We have to take 0.99. Okay, 2.39 minus 0.98, just subtract. So 2.39 minus 0.9, just subtract. We'll get a value of 1.40. We'll get a value of 1.40. 1.40. 1.40. That means this is 1.4. So from here 1.4. This is 1.4. Okay, this is this value. What is the value of this? This is 0.99. This is 0.9. For simplicity, I'm just doing this. But actually, you should not do like this. So you have to say one single line. You have to say mark distance of the distance. This is 2. This is 2.39. This is 2.39. You have to mark a distance 2.39 like this. So what I done here? 2.39. They asked to mark a distance of 2.39. The last decimal you have to consider 2.39. You have to take 0.99. You have to consider only on 0.99. So 2.39 minus 0.99, you get 1.40. So from here, in the main scale, just see here, up to this 1. So this is 1.4, 1.1, 1.2, 1.3, 1.4. This is 1.4. So from this 1.4, this is 1.4, this is 0.9. You just add, you'll get 2.3. Okay. For simplicity, I'm doing this. This no need to do that. You have to mark a distance of 2.39 only. If you do this, this is enough. If you do this is enough. But this is not over. We have to do one more thing also. So you have to mark a distance. Also 0.99. You have to mark a distance of 0.91 also. 0.91 also. So what you have to do? You have to mark a distance of 0.91. What is the last digit? 1. You have to consider only here. We have to consider 1. Last digit is 0.11. You have to consider 0.11. You just subtract. You just subtract. You'll get 0.80. You get 0.80. So then what you have to do? So after this, 0.1, 0.2, 0.3, 0.4. So after this is 0.8. This is 0.8. This is 0.8. This is 0.8. Then, so this is 0.11. This is 0.11. When you just add it, you can make a single marking. But I'm first for understanding. I'm just doing this. Only up to this is 0.11. So this is 0.91. This is 0.91. You have to mark it of 0.91. You have to mark it of 0.91. Okay, same problem. I'll do it manually. Okay, just so pin my laptop screen. Just pin my laptop screen. I'll take attendance. Pin my mobile screen. Pin my mobile screen. Same problem. I'm going to do it manually. So what are the data is given for the problem? What are the data is given? So representative factor is given. So RF is given. The RF is given 1 by 25. RF representative factor is given 1 by 25. So maximum length to be measured is given 4 meters. That is 4,000 mm. 4 meter. That is 4,000 mm. So we know length of scale. So you have to remember this two formula. Otherwise we not able to do this. So length of scale is so RF into maximum length. RF into maximum length to be measured. RF into maximum length to be measured. Okay, RF is given 1 by 25. So maximum length is given 4 meter. That is 4,000 mm. So you'll get a value of 160 mm. That is 16 centimeter. That is 16 centimeter. That is 16 centimeter. You got length of scale is 16 centimeter. So with this data, this problem it is given. Draw a Vernier scale. I already told you. Sometime it will not be given. So from the mark your distance only we have. Okay. See, 2 unit will be given. But if it is given 0.98, 0.26, so we can follow diagonal scale or Vernier scale. There is nothing wrong in that. Okay. So what I'm going to do here, but mostly it will be given construct a plane scale, construct a Vernier scale, or construct a diagonal scale. That will be given in the problem. Okay. So what I'm going to do, so we got length of scale is 16 centimeter. Okay. Length of scale we got is 16 centimeter. Then what you have to do, you have to draw a line, the value of 16 centimeter. You have to draw a line, horizontal line with the value of 16 centimeter. You have to draw a line, horizontal line with the value of 16 centimeter. You have to draw a horizontal line with the value of 16 centimeter. Okay. So we have to draw a horizontal line, the value of 16 centimeter. We have to draw a horizontal line with the value of 16 centimeter. Then you have to mark some height. Maybe you can take 2 centimeter. But diagonal scale, I already told you, you can take 5 centimeter. But plane scale and Vernier scale, you can take 2 centimeter or 3 centimeter height is okay. So, but I'm going to take now 3 centimeter. I'm going to take height of 3 centimeter. I already told you can take 2 centimeter, 3 centimeter. There is nothing. Even diagonal scale also you can take any this. Okay. So what is the scale height? So maybe 3 centimeter. Okay, you can take any height. Okay. And from here also, so draw a vertical line. So with the height of 3 centimeter. So just make this as a box. Makes this as a like whatever scale I'm using. So like that, I'm just making a scale like this. So this is your Vernier scale. So then what we have to do? Because length of scale is 16 centimeter. Maximum length is given 4. So 16 divided by 4. We get 4 centimeter. We have to divide into 4 subs. We have to divide this into 4 subdivision. Subdivision. Why I'm doing this? So based on length of scale and maximum length. Based on length of scale maximum length. We have to divide this into four subdivision. That is 16 divided by 4. You get 4 centimeter, and that is 8.
Sir, ஏன் சார் 4 ஆல டிவைட் பண்றீங்க?
Problem it is given maximum length to be measured is 4 centimeter. Problem it is given maximum length to be measured is 4 centimeter.
Okay.
Same methodology what we are following. Okay, same methodology. Okay, see in the problem RF will be given, maximum length to be measured will be given. Sometime RF will be given 1:25. Okay, in this problem it is given 1/25. So 1:25 means, so our representative factor is 1 divided by 25. Okay, so maximum length to be measured is given 4 meter. Okay, it is given in the problem 4 meter. So we have to divide the length of scale into 4. If the maximum length of scale is given 5 meter, we have to divide into 5. If the maximum length to be measured is 6 mean, we have to divide 16 divided by 6. It depends on value given. I'm not taking anything. I'm not modifying. So whatever the data, I'm just doing. Okay, length of scale divided by maximum length of scale divided by length of scale is 16 centimeter. So maximum length is given 4. So 16 divided by 4, we have to divide into 4 equal parts. You have to divide into 4 equal parts. That is from here 4 to 8, 12 like this. So here this is 0. This is 1, 2, 3. So this is meters. This is also meters. You can mark this also meters. Okay, then what we have to do? So I'm going to divide this into 10 subdivision. I'm going to divide this into 10 subdivision. I'm going to divide this into 10 subdivision. Okay, I'm going to divide this into 10 subdivision. This is 4 centimeter. This is 4 centimeter. So if we divide into 10 subdivision, you get 0.4, 0.8, 1.2, 1.6, 2, 2.4, 2.8, 3.2, 3.6, and 4. I'm just dividing this into 10 subdivision. So from each point, I'm drawing a vertical line. From each point, I'm drawing a vertical line. I'm drawing a vertical line from each point. From each point, I'm drawing a vertical line. From each point, I'm drawing a vertical line. From each point, I'm drawing a vertical line. So divide into 10 subdivision. So here also 1 meter, here also 1 meter. Then 1 divided by, we are divided into 10 subdivision. What is the each unit? 0.1 meter. Each is 0.1. Each is 0.1 meter. Each is 0.1 meter. Every value is 0.1. Okay, 0.1, 0.2, 0.3. So 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. Each subdivision is 0.1. So you have to mark from this 0.1 like this. If the values, for example, if I'm getting something here 0, 10, 20, 30, here 10, that each unit is 1, 2, 3. But 0, 100, 200, 300. Sometimes we'll get some problem 0, 100, 200, 300. Here only maximum only 4 meters. 4 meters. What is the 1 meter, 2 meter, 3 meter? What is the total length of the scale? Maximum length of the scale is what? 4 meter. That means 1 meter, 2 meter, 3 meter, 4 meter. That means the maximum length of the scale. The maximum, this length of the scale. Maximum length of the scale is okay. Only 4. Okay, only 4. 1, 2, 3, 4. You just count here. You have to get maximum length. So 0 to 1, 1. 0 to 1, 1. 2. So 3, 4. So 1, 2, 3, 4. This is the maximum length. You have to get this 4. Otherwise, we cannot able to do the problem. We cannot able to do the problem. From each point, draw a vertical line. From each point, draw a vertical line. I'm just giving names here. 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Like that, I'm giving name here. I already told you sometime if the value is here 0, 1000, 2000, 3000, here 1000. For each subdivision is 100. Okay, that depends on this unit and this unit. Okay, the value is 10, 1, 2, 3. The value is 100, 10, 20. The value is 1000, 100, 200. If the value is 10,000, here 0, 10,000, like that means each value is 1000. Okay, that depends on this value and this value. If you do into 10 subdivision, each unit is 0.1 like that. Then what you have to do? It is most important step. What you have to do? So the same value. This problem I'm getting 0.4. This problem I'm getting only 0.4. Whatever the value of this, whatever the value of one subdivision, whatever the value of one subdivision, you have to extend here. You have to extend this problem. The value is 0.4. This column, the value is 0.4. So from here with the value of 0.4, extend this. From here with the value of 0.4, extend this. And so from this, from 0, draw a vertical line. From this point, the extended point, draw a vertical line. From this, draw a vertical line. Maybe at any height, maybe 1 centimeter or 2 centimeter, draw a this height may be any distance based on your convenience. Here, draw this and connect this, make it as a box. Make it as a box. Then this we have to divide it into 10 subdivision. Actually, what is the total size of this? 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 11 subdivision. We have taken another one also. We have taken another one also. That is 11 subdivision. We are making this as a box. So this is called Vernier scale. This is called Vernier scale. So this is called main scale. This is called main scale. This is called main scale. This is called Vernier scale. This is called Vernier scale. This is called main scale. Then what we have to do? This we have to divide into 10 subdivision. That is 4.4. So what you can do? We already know one methodology. So what you can do? So draw one line here, cross line here. Okay, draw one cross line here. Okay, this divide into 10 subdivision. Divide into 10 subdivision. Divide into 10 subdivision. So I'm just taking 6 centimeter. That is 0.6, 1.2. You can take any suitable value. 1.8 and 2.4, 3, 3.6, 4.2, 4.8. And 5.4, I'm just dividing into 10 subdivision. Then what we have to do? Okay. It is not necessary you have to follow this methodology. What is the total length? 4.4. This is 4.4. So 4.4 divided by 10. Then what is the value you'll get? 0.44. So 0.4, the 0.44, you know, easy to mark 0.4, but 0.4 between 0.5, it's very difficult to locate the point. So that's what you can follow this methodology. Okay. So from last point of this and last point of this, just connect a line. Connect a line, and using minute after, if you just fix it, or using some set square, if you just move parallel lines, you'll get some parallel lines. So from this, draw a line here, you'll get one more point. Just move it, you'll get one more point. Just move it, one more, you'll get one more point. Just move it to next point. You'll get one more point. Just move it to next point, you'll get one more point, like this. Just doing somewhat approximately. If you have minute after, you'll get accurately. You'll get accurately. Just practice using minute after. Okay, just connect all this point. Just connect all this point. We got now this 11 subdivision is divided into 10 equal parts. Okay. Then from each point, draw a vertical line. From each point of this, draw a vertical line. So draw a vertical line. So this line will not be matched. This line will not be matched. You get somewhere in the middle. Because this is 10 division, we are doing into 10. But 11 subdivision, we are doing into 10. Okay, somewhere we'll get something like this. From each point, draw a vertical line. So this is your Vernier scale. This is your main scale. This is your Vernier scale and main scale. I already told you, we are taken 11 subdivision. We are taking 11 subdivision. The least count of the vernier is 0.01. Least count is 0.01. We are taking 11 subdivision. Least count is 0.01. So the first division, you have to mark here. This is 0.01. This is 0.01. This is 0.01. First division is 0.01. So next thing is, sorry, 0.11. Sorry, 11 into 0.01, you'll get 0.11. So 0.11. So this is up to this 0.11. What is the next one? 0.11. So 0.11 plus 0.11, you'll get 0.22. So this up to this 0.22 plus 0.11, you'll get 0.33. So this is 0.44. This is 0.55. This is 0.66. This is 0.77. This is 0.88. This is 0.99. So 0.99 plus 0.11, you'll get 1.10. You'll get 1.10. Get 1.10. Get 1.0. Then what we have to do? Okay, this we complete the scale, but they asked to mark a distance. They asked to mark a distance of 2.39 meter and 0.9 meter. They asked to mark a distance of 2.39 meter 2.39 meter and 0.91 meter. Okay. What you have to do now? Just see the last decimal 2.39. Okay, here 0.99. This last decimal and this decimal has to be matched. Otherwise, we cannot. It's very difficult to do that. Okay, any one division. Okay, if you're getting 2.30, it will be matched with 0. So if we get 2.39, it'll be matched with 0.9. If it is 2.38, it will be matched with 0.88. If it is 2.37, that will be matched with 0.77. But this problem, so 2.39 that is given, that will be matched with 0.99. That will be matched with 0.99. Just subtract 990. Okay, you'll get 2. You'll get 1.20. You'll get 1.2. You'll get 1.40. You'll get 1.40. Get 1.4, you'll get 1.40. Then what you have to do here, this is one more important step here. From 1 also, from 1 draw a vertical line, from 2 draw a vertical line. This also we have to make into 10 subdivision. This also we have to make into 10 subdivision, but for my convenience I'm going to do only here. So this make into 10 subdivision. So 0.4, 0.8, 1.2 like that. So yeah, only this 0.4, 0.8, 1.2, 1.6, 2. Each is 4 centimeter. 10 subdivision is 0.4 and 2.4 between here 2.4 and 2.8 and 3.2 and 3.6 like that. Okay, I'm just making some subdivision here. But if you subtract 2.39 minus 0.99, you'll get 1.40. Then what you have to do? So this is 1. So from 1.4, so draw a vertical line. From 1.4, draw a vertical line. This is 0.99. This is from 0.99. So draw a vertical line. To mention the dimension, draw a vertical line. So you have to connect this. You have to connect this. You have to connect this and draw an arrow. And say that this is 2.9 meter. This is 2.39 meter. So from here 1.40. So from here 0.99. When you just add it, you'll get 2.39 meter. 2.39 meter. And one more value is also given. Market distance of 0.9 meter. Market distance of 0.9 meter. So 0.91. Okay, this is the last subdivision is last decimal is 1. We have to consider here 0.11. We have to consider 0.11. Just subtract 1, you'll get 0, 8 and 0.80. You'll get 0.80. Then what you have to do? If you just count here 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 like that. Okay, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Okay, you'll get 0.8 somewhere here. So from this 0.8 and 0.11, from 0.11. So draw a extension line. Just connect this. So between your distance is 0.8. So your distance is 0.11. And just add it. What is the distance? It is 0.91 meter. 0.91 meter. Market distance. Market distance like this. You have to market distance like this. And is it clear? Is there any doubt? But I'll tell you what is the forward Vernier after some time. Is there any doubt still now? Doubt இருக்கா Chandru?
சார் கூகுள் கிளாஸ்ல போஸ்ட் பண்ணுவீங்களா சார்?
போஸ்ட் பண்ணுவேன். அது நான் போஸ்ட் பண்றேன். உங்களுக்கு ஏதாவது டவுட் இருந்தா கேளுங்க. ஓகே. you're not having doubt. Okay. Is there any Divya இருக்கீங்களா? Divya இருக்கீங்களா? Absent ah. Divya.
Sir?
ஏதாவது டவுட் இருக்காமா? ஏதாவது டவுட்?
இல்ல
ஏதாவது
சார்.
டவுட்? ஓகே. சிவனேஷன் ஏதாவது டவுட் இருக்கா? சிவனேஷன் ஏதாவது டவுட் இருக்கா?
இல்ல சார், நோ சார்.
Okay, once again, but I'll tell you. Okay, I'll tell you how to do by forward. We are done for backward Vernier methodology. There is one more methodology. Okay, but I'm not going to solve the problem. But there is one more methodology. I'll tell the methodology. So what is the difference between this backward Vernier and forward Vernier? So what we have to do? So everything is same. Everything is same. So we have to okay. I'll just complete up to this. This is So what we have to do? So 16 centimeter. Is it visible? Screen visible, Amma?
Yes, sir.
Okay. Okay. What I'm doing here with the same methodology, but same problem I'm doing for forward vernier. I'm doing for forward vernier. Okay, 16 centimeter. Then so from here 16 centimeter, making a scale like this. Same problem, but I'm doing for this problem is called backward vernier. Okay, if it is not given, you can follow for forward vernier or backward vernier. There is nothing wrong with that. So what I done here, the value of 16 centimeter. So the value of 16 centimeter, I made a scale. So this also you have to divide into 4 subdivision. Divide into 4 subdivision. Okay. So 4, 8, 12. Okay, just dividing into 4 subdivision. Draw a line here. Draw a line here. Okay, draw a line here. So draw a line here. Okay, this is this 6. Okay, and just give a name here 0, 1, 2, 3. 0, 1, 2, 3. This is meters. So this is called main division. This one is called subdivision, and upper thing is called vernier scale. Upper thing is called vernier. So this here also 1. So divide into 10 subdivision. You'll get 0.1 something like this. Sorry, okay, there is a small difference. Okay. There is a small change is there. Okay, what is the difference here is? So if it is a backward vernier, we are doing from this side. If it is a backward vernier, we are just doing from this side. If it is a forward vernier, what we have to do? We have to do this. We have to do from this side. We have to do from this side. We have to do from this side. So what we have to do here? So we have to give a name from here. 0.1, 0.2, so 0.3 like this. We have to give a name. We have to give a name from this side. We have to give a name from this side. We have to give a name from this side. So 0.1, 0.2, 0.3. So 0.4 like this. Okay, 0.5, 0.6, 0.7, 0.8, 0.9. We have to give a name from this side. Not only this, there is one more difference. Okay, in backward vernier, what we have done, we are giving name from this 0.1 like this here, and vernier scale also we are giving name from this side. We are giving name from this. So this is very easy methodology. This is very easy methodology if you follow backward vernier. But if you follow forward vernier, what is the problem here is? So we have to give a name from here 0.1, 0.2, 0.3, 0.4. We have to divide this into 10 subdivision. We have to give a name 0.1, 0.2, 0.3, 0.4, 0.5 like this. And one more thing is what you have to do. And backward vernier, we are taken 11, but here we are take only 9 subdivision. We have take 9 subdivision. From 9th subdivision, draw an extension line like this. In backward vernier, what we have done is we made one more extension here. Equal to this length, we made one extension. We make 11 subdivision. That's why 11 into 0.01, least one. So 0.11, 0.22 something. But here, what we have to do? So we have to mark from here 0.1, 0.2, 0.3 like this. And not only that, from 0.9, we have to take only 9 subdivision. We have to take 9 subdivision. So from 0.9, that is from 0.9, 9th subdivision. So draw extension line. And from here, draw extension line. From here, draw extension line. And make it as a box. Make it as a box. Make it as a box. Then this 9 we have to divide into 10 subdivision. This 9 we have to divide into 10 subdivision. We have to divide into 10 subdivision. You'll get something like this. I'm just doing it approximately. So you can follow the incline line. The same methodology you can apply. I'm just dividing this 9 subdivision. Actually, the total we are divided into 10 subdivision. From 9th point, draw a vertical line. Make it as a box. But 9 subdivision I'm going to divide into 9. Okay, actually this 9 subdivision I'm going to make into 10. I'm going to divide into 10 subdivision. This I'm going to make into 10 subdivision. Just divide into 10 subdivision. Just make it. Okay, or you can measure the scale and you can mark it. There's nothing wrong in that. But I'm doing approximately 4, 5, 6, 7, and 8. I'm just making into 10. Okay, you just see here in backward vernier, we have made 11 subdivision into 10 equal parts, but here 9 subdivision into 10 equal parts. So 9 into least count is 0.01. 9 into least count is 0.01. 9 into least count is 0.01. Then what we have to do? The first subdivision is 0.09. Next thing is 0.09 plus 0.09, you'll get 0.18. Next 0.18 plus 0.09, you'll get 0.27, like this. And not only that, we have to mark from this side. We have to mark from this side. We have to mark from, okay. If it is a backward one here, we have to mark from this side. We have to mark from this side. But if it is a forward one here, we have to mark from this side. We have to mark from this side. Okay. And first is 0. Next thing is 0.09 and 0.18, 0.27, 0.36, 0.45, and 0.54, and 0.63, 0.72, and 0.81, and 0.90. 0.90. And not only that, what is the gap? What is the gap of this? There is a gap here. What is the gap of this? Here 0.1, 0.1. What is the gap of this? We are taking only 9 subdivision. Okay, each subdivision is 0.1. What is the gap of this? This is 0.1. This gap is 0.1. This gap is 0.1. Okay, scale is over. So what is the difference between backward and backward vernier? So what we have done? Okay, 10 subdivision. We made one more subdivision. We made 11. So 11 we are divided into 10 equal parts. We have made 11 into 10 equal parts, and we are giving names from this side. Okay, 0.1, 0.2, 0.3, like that. We are giving name here. Here we are marking 0.1, 0.22, 0.3, like that. We are just giving name here. But in this scale, in this particular scale, in forward vernier, what we have done here is we have to give name from this 0, 0.1, 0.2, like this. We have to give name here. And for 9 subdivision, we have to divide into 10. Okay, 9 subdivision we have to divide into 10 equal parts. So 9, okay, 9 into least count is 0.01. So 0 into point. Okay, first is 0. Next thing is we have to mark from here. We have to give names from here. 0, 0.09, 0.18, 0.27, like that we have to give. And what is the gap here? 0.7. What is the gap here is 0.1. Okay, this is somewhat so difficult to mark. For example, I want to mark same value, 2.39 meter. I want to mark 2.39 meter. The same thing you have to do. So 2.39 meter. So what is the division here? What is the last 2.39? So where you will get here 0.09. Where you will get 0.09. You get 0.09. Just subtract 0.09. Last is 0.09. You will get 0, 3, 2.30. You get 2.30. So what you got is you want to mark a distance of 2.39 meter. So here each subdivision is 0.09. Each subdivision is 0.09. So 2.39 minus 0.09 will get 2.30. You'll get 2.30. You'll get 2.30. So what you have to do? Okay. So here, so each subdivision you have to mark. You have to mark each subdivision. You have to mark each subdivision. You have to mark each subdivision. You have to mark 2.30 plus 0.09. 2.30 plus 0.09. Okay. So this is somewhat confusing. Just watch here. There are some gap also 0.9. So this is 0.9 already is there. From here 0.1. From here there is a gap of 0.1. So 2.30 and 2.3, 0.1. So I'm going to mark here 2.2. I'm going to mark 2.2. So 2.2 plus. So 2.2 plus 0.1 will get 2.3. Okay. So 2.2. So 1, 2 and 0.2. So 2.2 plus 0.1, 2.3. And what is the remaining is there? 0.09. So one subdivision is 0.09. You have to mark 0.09. You have to mark 0.09. So this is 0.09 and 0.1. 0.09 plus 0.1 plus 2.2. You have to mark this as here. So this is 2.2. Already here there is a gap of 0.1 and remaining is each gap is 0.09. So 0.09. When you just add it, you'll get 2.39 meter. You'll get 2.39 meter. So if this is confusing for you, just follow that backward vernier. If this methodology is somewhat difficult for you, just follow backward vernier method. Okay. Clear ka doubt irukka? Clear ka doubt irukka? I'm going to close. Is there any doubt?
சார் ஆனா எந்த மெத்தட்ல வேணா போடலாம்ல சார் பேக்வர்ட்
மெத்தட்ல வேணா போடலாம்.
ஓகே சார்.
ஆனா இதுல என்ன ஒரே ஒரு ப்ராப்ளம் அப்படின்னா நீங்க வந்து கரெக்டா மார்க் பண்ணீங்கன்னா இந்த கேப்பும் இருக்கு 0.1 இருக்கு ஒரு ஈச் சப்டிவிஷன் இஸ் 0.09. இப்போ இங்கேருந்து மார்க் பண்ணும்போது பார்த்தீங்கன்னா இது கரெக்டாக நீங்க ஈஸியா பண்ணிடலாம். பட் இங்கேருந்து பண்ணும்போதுன்னா யூ ஷுட் நோ 0.09, 0.18, 0.27, 0.36. ஓகே, திஸ் வேல்யூ இஸ் 0.36. சரியா? இந்த வேல்யூவும் கன்சிடர் பண்ணணும். அடுத்து 0.1 கன்சிடர் பண்ணணும். அடுத்து இந்த டிஸ்டன்ஸையும் மார்க் பண்ணணும். எல்லாத்தையும் சேர்த்து கரெக்டா மார்க் பண்ணணும். சரியா? எனி டவுட்? I'll just again I'll just complete the recording. Any doubt we will discuss. Otherwise